So good morning, sir. I am Roste Nerdas Arias. So in this video, I report area measurement in Simpsons method and Planimeter method.
Area measurements in Simpsons, continuation of the report of Ms. Janeline Estoya. So, Simpson's rule or Simpson's method is a numerical method that approximates the value of definite integral by using quadratic functions. So this method is named after the English mathematician Thomas Simpson on 1710 to 1761. So Simpson's rule is based on the fact that given 3 points, we can find equation of a quadratic through the points. So this is the Simpson's rule formula. A Simpson's rule of A of B of A, the f times x is approximate to the width of over 3 times f of x0 plus 4 of x1 plus 2f of x2 plus 4x of xn minus 1 plus f of xn. So where the width of the rectangle equals b minus a over n, and the approximate value of 8 plus the width of the rectangle of I. So the n is a subdivision of the functions. It is an even number, and a is a point of the start of the function graph, and b equals the point at the end of the function graph. So this is the diagram of Simpson's rule showing approximation using Simpson's rule. So there are two variations of the rule, the Simpson's 1/3 rule and Simpson's 3/8 rule. So Simpson's 1/3 rule, or just simple rules, in German and some other language, it is named after Johann Kepler, who derived it in 1615 after CE. It is used for wine barrels or barrel rule, couplage, Fassler, and the approximate equality in the rule becomes exact if f is a polynomial up to quadratic degree. So Simpson's 1/3 rule is an extension of the trapezoidal rule, in which the integrand is approximated by a second-order polynomial, and the Simpson's rules can be derived from the various array using Newton's divided difference polynomial and the method of coefficients. So Simpson's 3/8 rule. So Simpson's 3/8 rule, also called Simpson's second rule, requires one more function evaluation inside the integration range, and is exact if f is a polynomial up to cubic degree. So this is the formula of Simpson's rule, and the Simpson's rule of y x equals the width h over divided by 3 times y0 plus 4 y1 plus y3 plus y5 plus y minus n plus 2 times y minus 2 plus y4 plus y6 plus minus 2 plus yn. So that is the formula of Simpson's one-third rule. So this is the so next is Simpson's 3/8 formula. So Simpson of x times f times x is approximate the 3h/8 divided by of x of f over of x of a plus 3f times 2a plus b over divided by 3, where b minus a equals 3h. So the error of this method is b minus a times pi over 650 of x times 4 equation, where equation is some number between a and b. So this is the example of Simpson's rules. So first one is a function of x is given by the table of value. Approximate the area under the curve y equals f of x between x equals 0 and x equals 4 using Simpson's rule with n equals 4 intervals. So, so the solution is for n equals 4 subintervals. Simpson's rule is given by the following equation. So Simpsons of S of 4 or approximate as Simpsons 4 is the width of rectangle over 3 divided by f times x of 0 plus 4f of x1 plus 2f times x2 plus 4f of x3 plus f of x4. So the width of the interval is b minus e over n equals 4 minus 0. So the solution is calculate the function values at the points. So f of x0 equals f of 0 equals the square root of 0 equals 0. So f times x1 equals f of 2 and f of 2 is square root of 2. So f of x2 equals f4 and the square root of 4 is 2. And the f of x3 equals f of 6 and the square root of 6. So f of x4 equals f of 8 equals the square root of 2 is 2 square root of 2. So all these values into the Simpsons rule formula. So the Simpsons rule is approximate the x of dx as approximate the width of the interval divided by 3 cos times f of x0 plus f of x1 plus 2f times x of 2 plus f4 times x3 plus f of x4. So equals 2/3 of 0.4 square root of 2 plus 2.2 plus 4 by square root of 6 plus 2 square root of 2. So equals 2/3 divided by 6 square root of 2 plus 4 the square root of 3 approximately equals the 18 4 18 of 14.86. So the true solutions for the integral is the Simpsons rule of 8 of 0 and the square root of x dx and is equals to x plus 1 half dx equals of x of 3 2 divided by 3 2 times 8. So equals 2/3 the square root of x3 equals x the square root of x3. So the square root of x3 equals 2/9. So i-times siya maong 16 square root of 2 and equals 32 to the square root of 2 divided by 3. So so 32 to divide the square root of 2 divided by 3. So equals 15.08. So hence the error in approximating the integral is 15.08 divided by 14.06 sa una nga nagawas na solution sa pag-substitutes. So nakuha nato ang 15 sa iyang integral sa true solutions. So i-divide nato siya og up the solutions of for the integral. So equals 0.015 or 1.5%. So mao na siya ang ihang approximate in the integral in using the Simpsons rule. So let's continue the planimeter method. So what is the planimeter method? So the planimeter method is the area of the land in place surveying is determined by various methods. So planimeter method is land sa mga yuta ka na mag-measure ka, like for example magsukod kag yuta kung pila ka hectares or pila ka kuan square meters ang imuhang ang sukod para sa para magbalaan kung pila pila na siya tanan sa isa ka land sa diameter yun. So this area is determined by a particular method is used for many purposes such as determine the quantities of earthwork, fixing the boundary of the field, and thus calculating the area based upon which the revenue is paid. So the metric units are area of square meter or hectares. So revenue is paid. So like for example, magkakagbalay. So dapat mogamit ka og planimeter to measure kung pila jud para dili masudla or dili mangisog imong katapad na yuta. So, a planimeter is a precise instrument which measures the area of land of any shape with more accuracy. So there are two types of planimeter. So the answer polar planimeter or the roller planimeter. So the various components parts of polar planimeter is as follows. So tracing arrow and tracing point, the anchor arm, rotating wheel, and graduated drum, this and magnifier. So this is the picture of the planimeter. So na diri ang touching screw, burner wheel, dial, and anchor arm to clamp na siya. So it is consists of two arms high head at a point known as the pivot point. So one of the two arms is anchor arms whose length is generally fixed. So anchor arms has got anchor point which fix either inside the plant or outside the plant depending upon tracing arm reach. So other arm is called tracing arm having tracing point at its end. So the length of the tracing arm is varied and by means of a fixed screw which is attached with a slow motion screw. So the mo ni siya ang example in the Planimeter method solutions. So the procedures to find the area of the plant. So the anchor point is either placed outside or inside the depending upon whether the area is small or big. So a point is then marked on the boundary of area and tracing point is skipped over it. So the initial reading of the wheel is then taken. Then the tracing point is moved along the boundary till it comes to the original point. So A equals M times F minus I submit minus I over 10 N plus C. So, so where the F is final reading, I is the initial reading, M is a multiplying constant, it is equal to per area or per revolutions of that Tyler. So N equals the number of times the zero marks of dial pass the fixed index mark. So C is the instrument's constant. So the example, an area was measured using a planimeter with anchor point inside the figure. So the initial and final readings were 4.129 and 6.387. So the zero marks on disc pass the fixed index mark once in clockwise directions. So if the value of m equals 100 square centimeter and constant of the instrument equals 24.686, so we need to calculate the area of the figure. So the final reading is 6.87, so there is the pit. Ang initial reading is 4.129. The multiplying constant is 100 square centimeter. So the number of times is I and constant is 24.686. So the solutions, so the number of, so I equals the initial reading is 4.129 equals, and F equals 6.387, 3.87. So the multiplying constant equals 100. So the C, or the instrument constant, equals 24.86. So the number, so N, so the number of the zero is I. So where is A equals M times F minus the square of 0, so 10 and plus C. So, A equals 100 times 6.387 minus 4.127 plus 10 times 1 plus 24.687. So, so, so the area equals, so the area, so A, so the area equals 3,694.4 centimeters. Kaya i-plus mo sa tanan, kaya i-times sa 100. So, 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 let's go back to the, various components or parts of the polar planimeter. Polar planimeter is the tracing arrow, and the tracing point. So, tracing point is the movable needle point which is connected to tracing arm. So this point is move over the outline of area to be measured. So anchor arms is used to manage the anchor positions or needle point positions on the plan. So it once end is connected to weight a needle point and other end to the integrated wheel. So the rotating wheel is fixed in the integrating unit, which helps to measure the tracing length. So it is used to set the zero of the scale. So the dex is scale, which is the best set zero when level using setting wheel. So wala siya diri. So I have video clips on the measures of land surveying in Planimeter. So
We use all kinds of measuring tools in protractors, squares, and tape measures, etc. These work fine for small and medium-sized projects, but what if we need to lay out something big, like a road, bridge, dam, or pipeline? Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're talking about one of the civil engineer's most important companions, the land surveyor. And we're going to do a little bit of surveying you can try at home. This video is sponsored by Blue Apron. More on that later. Surveying is essentially the science of taking big measurements. And you've probably seen these guys on the side of the road looking through fancy equipment on a tripod. Just about any civil engineering project starts with a survey to determine the legal boundaries between parcels of property, the location of existing infrastructure, and the slopes and topography of the land. Humans have always had a penchant for building big stuff, which means surveying is a career full of history and tradition. Behind every wonder of the ancient world was an ancient geometry nerd who laid out the angles and alignments during construction. Surveying is also how we created accurate maps of the continents, like the Great Trigonometrical Survey of India, which took almost 70 years to complete. I personally think everyone should aspire to accomplish something in their life that can be prefixed with the words Great Trigonometrical. The ubiquitous tool for surveying is called a theodolite, and its one job is to measure the angle between 2 points. Combine those angles with distances from a chain or tape measure, and you can triangulate the location of any point using trigonometry. Modern theodolites, called total stations, can not only measure angles, but distance as well, and they have onboard computers that can do the calculations and record the data for later use. When you see a surveyor peering through a funny telescope, it's probably a total station, and he or she is probably sighting a reflector to record the location of a point. That's just scratching the surface of sophistication when it comes to modern surveying tools. With GPS and unmanned aircraft, things can get a lot more complicated. But I've got a few ways you can do your own topographic survey at home with fairly basic and inexpensive tools. Maybe you've got a drainage issue on your land. Maybe you're planning a landscaping project. Or maybe you just want to exercise your God-given right to take measurements of stuff and write those measurements down on a clipboard. That's my kind of recreational activity. My goal is to perform a leveling survey of my front and backyard, which is just a way to get the relative topography for an area. I laid out a grid of points on a map of my house and then transferred those points to real life using pin flags. Now I just need to pick my datum or base point and measure the relative difference in height between that point and all the others. I tried a few ways to do this, and there are no sines, cosines, or tangents required. First, a sight level, which is essentially a combination of a telescope and a spirit level. To use it, first get a buddy or a willing spouse to hold a surveying rod on the point of interest. Now look through the sight at the surveying rod and raise or lower the end until the bubble is centered on the line. Once it's centered, you know you're looking at a point that is exactly level to your eyes. If you subtract the height of your eye line with the height measured on the rod, that's your elevation. It's not a precision technique, but it is cheap and simple, which is the most you can usually hope for in any part of a home improvement project. The next way I tried is a water level, which is literally just a length of clear vinyl tubing filled with a liquid. As long as there are no bubbles or kinks in the line, the free surface at each end of the tube will self-level. I kept one end at my datum a fixed height and measured the height of the water at the other end as I carried around to each of my points. It's a little more unwieldy, but it does have a distinct advantage. No line of sight required. You can use this method around corners or behind trees with no problem. And again, it's cheap and simple. The third method I tried worked best for me, my laser level. Here's the thing, I really like lasers. I relish any chance I get to use them in a constructive way, and this is perfect. The laser level creates a perfectly horizontal line that can be used to line up cabinets or pictures or tile, but it also shows up perfectly on a surveying rod. You don't need a helper for this method, but you do probably need to wait until dusk unless your laser's really bright, or you have these sweet laser enhancement glasses. This isn't the cheapest solution for a DIY land survey, but it is the fastest one I tried, and it's a tool a lot of people already have. Surveying is one of the oldest careers in the world and one of the most important. Why? Because land is important. If you own some, it's probably your most valuable asset, and even if you don't, you're pretty much stuck to it no matter where you go. As a career, surveying is a fascinating mix of legal knowledge, field work, and technical challenges. And since civil structures are too big for conventional measurement tools, the surveyor is one of the most important companions of the civil engineer. Thank you for watching, and let me know what you think. Thanks to Blue Apron for sponsoring this video. We're still in the process of getting settled into the new house. After a long day installing lights in the workshop or throwing away all the junk left by the previous owner, it has been really nice not to worry about.
So that's all for my report. So if you have any questions or clarifications, just ask me when we have a meet. Thank you and God bless all.